Today's presentation, I'll try to give you a sketch about how to expand BCI technologies. Usually this is motor B300 based systems, motor imagery based systems, B300. And we need to go beyond that. We need to give communication systems more of a rehabilitation spin to send it in that direction. And I'd like to say that there are no publications about using BCI technologies for psychiatry, because psychiatry is about dealing with the human spirit, with the psyche. The first thing I would like to focus on is this. The human brain took several million years to form, but in the past 50,000 years it has virtually not changed. But due to several circumstances, of which I will only name two, the natural selection has stopped. The stupid don't die, the weak don't die, they leave offspring. I don't want to minimize the importance of the stupid people or the weak people, but everybody gets a job, everybody gets a place to live, and it turns out that in this society everybody has the right to live, and there is no natural selection. There's no segregation on account of stupidity or intellect. And the second observation that I would like to make, that it is more expedient not to change the body, but to increase intellect. If it's cold, you don't need to grow any hair, you don't need to grow fur, you just build a nice warm house. That's why the majority of people who work in the area of evolutionary biology, they believe that this general evolution for the human being stopped 50,000 years ago, which means that we live with the kind of brain that stopped developing 50,000 years ago. And it's quite surprising how we still live with this brain. And especially is it surprising how we can live after the changes that occurred 20, 30 years ago, because the information load in our brain increased dramatically 20 or 30 years ago. Because the output generated by humankind is becoming more and more about generating information rather than physical product. So more and more information is generated, and this is all something that we become exposed to, and things go increasingly digital. I go to a store, I take some product, and I couldn't come through the checkout counter, and then the checkout counter assistant didn't even have to know the name of the product, only the code of it. And that creates an additional unprecedented load on the human brain. So the question is, will our brain survive this too? And by the way, remember that the last release of our brain, of our software, came out 50,000 years ago. So this is an assessment of the human health. This was a scientific publication showing the dynamics of cardiovascular and oncological diseases. And we see that the dynamics is positive. We see a downward trend, and this is mostly attributed to healthcare and healthy lifestyles that people lead more and more these days. Now look at neurological disorders. This paper, the same paper, says that neurological disorders have increased dramatically since 18 1989 to 2011. And the same trend is in the area of psychiatry. Perhaps this is the first sign showing that the brain that worked perfectly well 50,000 years ago, that worked very well until the information age, begins to fail in this, under this pressure of information. Perhaps you don't feel this, you think that things are great and this information technology is a good thing, but we're different, and perhaps part of our population maybe are more vulnerable to the increased information load. In fact, it's quite possible that the brain is indeed overloaded and something has to be done. Let's look at a specific sub-area of psychology. Perhaps BCI can help psychiatrists. I know that, of course, you can use medications, perhaps surgery can play a role, but let's look specifically at neurotechnologies. And at this point, I'd like to say that 870 million people in the EU alone are at risk for psychiatric disorders. And several waves have been identified. These are these waves. The first wave was to say that everything is due to bad nerves. The second wave, starting from 1950, people believed that psychiatric disorders were mostly due to genetic factors, and in wave 3, cellular processes were thought to be the culprit. But now we're in wave 4, and in wave 4, psychiatrists believe that psychiatric disorders are due to information overload, poor information load coping tactics. We know that some people spend more effort processing information and other people spend less. We have to really understand this. We have to study this, and perhaps computational psychiatry has a big role in finding answers to these big questions. What do we suggest, or what can we suggest? Okay, we can suggest a lot at this point, but we do have something already. For example, P300-based BCIs. This technology can identify whether or not the symbols are interesting to the subject. Classical paradigm, we highlight rows and columns. Since we register EEG continuously, we can always find the small reactions to these highlighted rows and columns. We are talking about 2 to 3 microvolts. Of course, you can't find them with the naked eye, you have to pre-process the data, but these reactions are different. So there is a significant amount of variability in them. And here is a neurophysiological trick. Perhaps I will repeat something that everybody knows. The neurophysiological trick I'm talking about was done back in 1980. We can figure out what letter a person had in mind before the presentation of the stimuli. If the conceived letter is highlighted, then the reaction will be slightly different. And you can catch this in this loop, and this loop represents a brain-computer interface. I believe many people present here in this room know what this is. we see the P300 ERP. This is a rare case. Usually they are not so pronounced. This is the reaction to the rows without the necessary letter, and here is the reaction to the rows with the desired letter. So, if we study this entire range, there are other components that add more valuable information that helps us identify. For example, this N2 range that helps us identify what letter the person, the subject, had in mind. So as a result, in our lab we got 95% accuracy rate of this BCI. So in other words, we guessed the correct letter in 95% of the cases. But how can we adapt this for psychiatry? Let's say, for example, we replace the letters with pictures. And these pictures are special pictures. For example, they are deliberately selected. These can be several panels of pictures. And then we can ask the patient to look at the screen, and all of them flash. And even if the person is not specifically instructed to look at a specific picture, perhaps internal interest or some emotional trick forces the person to, or encourages the person to look at a specific picture, and then we're going to get a P300 response to a specific picture. And we are going to use this, we can use this as a valuable metric. We can create another set of pictures. So this is just a suggestion for scientific research, and as a result, we can detect, let's say, an emotional marker, for example. We can test pictures by that. But when we get a sign, we can get an automatic detection system. And then this information, the information from this BCI, can be used for the adjustment of therapeutic interventions. This can become a loop. And I'm not going to continue my fantasy. This is just a suggestion. But the question is whether or not this will work. Let's say, for example, the subject didn't receive any instructions, but still shows a large P300. We did some tests, we selected a subset of words. We selected a column of negative words, positive words, and neutral words. So, we have actually 3 levels of neutrality, 3 levels of positivity and negativity. We took all of these, we took only the strongest negative, positive, and neutral words, just to make sure that that everybody agrees that these words are indeed negative, positive, and neutral. So, we present, in that case, we present not letters, but as words. One word by word. Every word, one word at a time. Continuously. And you can also slow down the presentation rate. Let's say, for example, we want to test negative words. We can show negative words more rarely, but others more often. The person, remember, is not instructed what to look for. Of course, we looked at different components in these visual evoked potentials. We didn't find anything special, but this is what we got. This is what we got from the passive observation of words. If we flash rarely flash positive words, that's the amplitude we get. These are P300 amplitudes in microvolts. If we show negative, then we get the reaction that is much stronger. However, the conditions were the same. Both were shown rarely and neutral. Again, we have the same amplitude. In fact, negative ones should have produced a larger amplitude. And in fact, this situation repeats itself for other channels, for other subjects. For some reason, positivity elicits a smaller amplitude. In other words, the response, the P300 response, is smaller to positive words. So P300 can serve as a marker of positivity of the words presented. And these tests were done on healthy subjects. If you take some negative stimulus and you present it under a passive attention such condition and in an active condition. For example, we instruct the people to only pay attention to negative words. In that case, we get an even stronger P300 amplitude. With active attention, this amplitude is even larger. But let's remember, in passive attention is different than active attention. So this is a nice tool for psychotherapy. If we had active attention here, the patient's consciousness is involved, the doctor wants him or her to pay attention to the negative. But in that case, in the previous case, the subject doesn't know what the researcher wants to get from the subject. Although the P300 here is lower, it's still statistically different from the negative. The positives are different from negatives. And here we have a situation in which we solved a very specific task. We worked with anorexic neurotic patients. These are real psychiatric patients. And the question was, why do people abstain from food? Are they repulsed by food? Or maybe there were some other causes. So we showed different pictures of food and pictures of the human body. Thin, fat persons. And it turns out that pictures of food are less interesting to people, to those neurotic patients, than pictures of the body. So the problem is not that the person abstains from food, but because the person believes that that's going to lead to a body weight increase, which they are afraid of. And there is another effect which I would like to share with you. It has already been mentioned here today. The same setup, but these lights will light up not on the matrix, but on this artificial hand, which is actuated by electric motors. And you can make those lights flash, and then the motors are connected to fingers. If a person attentively looks at the LED on the middle finger, we detect the interest of that person to that middle finger. We actuate the movement of this finger. So we detect the intention of the person to move that finger, but the movement of their own finger. So we drape the real hand, we only show the artificial hand. So will this produce an effect in the motor cortex?
perhaps you can activate the motor cortex, and that's a totally different thing than looking at all these different bulbs and not even their own hand. It turned out that in experiments with transcranial magnetic stimulation, when the magnetic impulse stimulates the area around the wrist, and you can find a zone with a low amplitude and see the muscular response only. There at the threshold intensity you can stop and then make the average amplitude, medium amplitude a few times, and then ask the person to play with those fingers of that mechanical arm or hand, and then it turned out that if a person works in that situation, the muscle response goes up by a standard stimulus. It goes up. It means that there's additional amount of activated cells in the cortex, and even the same small stimulus is enough to activate them, and it means we'll get better muscular response. It means that by using this technology we get the same effect on activation of the motor cortex, and these could be more efficient, and we need to check that. At least it's interesting that you can have different situations with your hand. You may want to bend your middle finger, or you wanted to bend another finger and it didn't work, but the maximum activation happens if a person makes a mistake. If he does everything right, and he had this one finger in mind and it worked, there's also motivation, but it's not that high. These are some of the features of this technology that we can use for different rehabilitation procedures. Thank you. Thank you, Dr. Kaplan. And let's see if we have a couple of questions. Everything seems to be clear. Thank you. Andrei Nikolaevich, head of the physics department here at the Samara University. We have shown young and handsome men instead of anorexic individuals, would the result be the same? And well, it means that this might happen. There are different options. This was just an example for a specific case to understand whether it was about the body or the food.